Hello, beautiful people, and welcome. Today we're going to be going through adding and subtracting fractions. These fractions will be improper, and then we're going to go through some fractions that contain like denominators or common denominators, and then we're going to go through fractions that have different denominators or unlike denominators. Again, disclaimer, if you notice any mistakes, I am human. Just let me know where the mistakes occur. That way we both can learn from them. If you hear any loud noises or anything like that, we are recording from home today, so please disregard those noises. And again, I apologize in advance if they occur. All right, let's get started with example number 1. Now, in example number 1, let's do something with a common denominator. Now, if you haven't, go ahead and head over to my previous video. That video is going to be called Adding and Subtracting Fractions Steps. So go through that video, look at all of these steps that I have written out of how to add and subtract fractions. In that video, you're going to notice that I did 2 examples that are both addition. So I want to spend a little bit more time on subtraction in this video. And yes, that does include negatives. So let's go ahead and start something with a common denominator. So let's do 5, 6 minus 3, 6. So step number 1 is something that is common. So these are common denominator fractions. And we're looking at 6 and 6. So our step number 1, let me change colors. Step number 1 is going to be to look at the denominators if they are the same. Yes, in fact, they are the same. So if your denominators are the same, leave them and just bring over to your answer. So we're going to not do anything with them. We're just going to bring that over to our answer. So then we have 5 minus 3. So now we are on step number 3, and it says take your numerators and add and subtract like usually. Okay. So I'm going to take my numerators. Here's 5, here's 3, and here's a minus. So I'm going to say 5 minus 3. And then we're going to subtract like usual. So we have 5 minus 3. I don't know what that is, so I'm going to use counters. So when you're using counters, you have the sign that is in front. So if there is nothing in front of 5, we know that that means 5 is positive. So I have 1, 2, 3, 4, 5 positives, and I have 3 negatives. 1, 2, 3. I'm going to go ahead and circle my 0 pairs, and all that means is 1 negative and 1 positive. They cancel out, and that makes 0. So 1 negative, 1 positive cancels out. That makes 0. Negative and positive, that is 0. So that's why we call them a 0 pair. And then you're looking at what's left over. I have 2 positives left over. So then here, 5 minus 3 is positive 2 over 6. And now I do want you to simplify, okay? So at this step, simplify your fractions. Now I'm not sure how your teacher does it, how you were taught, but this is how we do it in my class, how to simplify fractions. We're gonna go ahead and write down the factors. So what are the factors of 2? What times what is 2? The only thing is 2 times 1 is 2. Then what times what is 6? Now you can write 6 times 1, but that's very unhelpful because we also know that 3 times 2 is 6. I'm going to write 3 times 2. I'm going to cancel out or undo the same numbers. For example, I see a 2 on top and I see a 2 on the bottom. So I'm going to divide that. This symbol, this line right here in a fraction means division. So I'm going to divide. And so what am I left over with? I'm left over with 1 on top and 3 on the bottom. So 5, 6 minus 3, 6 is 1/3. Now we are talking about improper fractions. This is not an improper fraction. This is a regular fraction. Improper fraction, let me go ahead and note that. Improper fraction just means the numerator is bigger than the denominator. And I don't mean how you write it. We're not talking about writing a number size-wise that's large. We're talking about the value of the number. So 1 is smaller than 3, so it is not an improper fraction, it's a regular fraction. But let's say, let's do example number 2, and we'll do an improper fraction. Example 2 is going to be subtraction with an improper fraction. So let's do example 2. So an improper fraction means the numerator is larger than the denominator. So let's do 12 on top and let's do 8 on the bottom. So 12 eighths is this fraction, 12 eighths. And again, we talked about having subtraction here a little bit more. So 12 eighths minus, let's do 3 fourths. And then we're trying to figure out what that equals to. So again, step number 1 is look at the denominators. So I'm looking at my 3 and my 4. And I'm noticing, I'm looking at my 8 and my 4. And I'm noticing 8 and 4 are definitely not the same. So I know I have uncommon or different denominators. Unlike is another term. So I know I have different denominators. So I'm looking at the right-hand side of my notes again. If you haven't already, go ahead and head over there and look at our steps here. That's what I'm following. So step number 1 is look at the denominators. Step number 2 is if the denominators are different, list the multiples of each. So what I'm going to come over here is I'm going to start with 8. So I'm going to say 8 times 1, 8 times 2, 8 times 3, 8 times 4. How many do I need? I don't know. I'm just going to list a few and hopefully we can get lucky with whatever we listed. If it's not enough, you continue listing. So 8 times 1 is, let me change colors, 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. And again, how do you know that? Just keep adding 8 to each jump, or you can multiply. Now let's do the same thing with 4. So I have 4 times 1, 4 times 2, 4 times 3, 4 times 4. How do we know we have enough? We have enough when one of our multiples matches. So whatever number is here needs to match to whatever number is here. Now, not all of them will not match. All numbers will not match. We're just looking for one, the smallest number that matches. All right, let's do 4 times 1 is 4. No matching yet. 4 times 2 is 8. There is a matching. So then you stop. So this is your multiple. So this is going to be your new denominator. So this is your new denominator. Now we're looking at step number 4 is multiply each fraction by its multiplier. And before I even do that, step number 3 was stop listing multiples when you have a matching multiple. So we do. So here's our matching, 8 and 8. That's going to be your new denominator. In order to get to your new denominator, you need to have your multiplier. So what did we multiply? Well, we multiplied 4 by 2, and we multiplied 8 by 1. So now I am at step number 4 again, which says multiply each fraction by its multiplier to get the denominator to be the same. Rewrite your fractions with space. So I'm going to do that. I'm going to rewrite each fraction, but I'm going to give it some space. So 12 eighths minus 3 fourths equals, and I'm giving it some space, and it seems like it's a lot of space. Don't worry about it. We're going to fill that in. So step number 4 says multiply each fraction. So I'm going to multiply this fraction right here. I'm going to multiply top and bottom. You have to do the same thing on the top and the bottom. On the top and the bottom, what is my multiplier? My multiplier is 1. So I'm multiplying top and bottom by 1. And again, here, what is my multiplier? My multiplier is 2. I'm going to multiply top and bottom by 2. All right. And that brings us to step number 5, simplify and solve. So, okay, let's simplify and solve. 12 times 1 is 12. 8 times 1 is 8. 3 times 2 is 6. 4 times 2 is 8. Okay, I'm simplifying this, and I'm simplifying this. My minus has not changed, it's still there. Okay, now I'm going to have common denominators, so my denominators are the same, so I'm doing nothing with them. Bringing that over, and I'm going to do exactly what we did in example number 1. I'm doing 12 minus 6. And again, if you need your counters, go ahead and do that. If you don't need your counters, I recommend using your fingers. Your fingers are fantastic. So I have 12, and I'm going to take away 6. So 12, 11, 10, 9, 8, 7, 6. So 12 minus 6 is 6. So I have 6 eighths. And again, simplify. So I'm going to bring that over here. I have 6 eighths. Just like we did in example number 1, I'm going to list the multiples of, I'm going to list the factors of 6. So what times 1 is 6? What times 1 is 8? So what times what is 6? 3 times 2. Don't use 1 unless that's the only thing that works, okay? Refrain from using 1 as your factor. The only time 1 is okay is if you have a prime number, which means 1 and that number is only the only factor. So refrain from using 1. So 8 is 4 times 2. Again, we're going to undo, we're going to divide. I see a 2 on top, I see a 2 on the bottom. That divides out to 1. So what do I have? I have 3 left on top, and I have 4 left on the bottom. Now you may need to do this multiple times. So if here you wrote down factors that could be factorable, like further, then you could potentially need to do simplifying again here. So 12 eighths minus 3 fourths is equal to 3 fourths. Okay, guys, let's do another example. Example number 3. Let's throw in a negative in this example. Now, we have done subtraction, and subtraction is kind of like having a negative, but I'm gonna throw in an actual negative for you. I'm gonna say negative 5 thirds minus 3 fifths. Let's do 3 sevenths. That way we don't have the same number. Okay, step number 1, look at our denominators. Are our denominators the same? No, they are not. They are different. So step number 2, if the denominators are different, list the multiples of each. So I'm going to come over here and I'm going to say 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, 3 times 7. How do I know I have enough? You know you have enough. I'm going to actually give you an answer here, like a legit answer. You know you have enough if you have both numbers of the denominator in there. So 3 and 7. Now you can get a common multiple before you get there, but if you really want to know a stopping point, make sure both numbers are in there. So for example, we're going to do 7 times 1, 7 times 2, 7 times 3. I have both numbers in. I have 3 and a 7, so I'm going to stop. 3 times 1 is 3, 3 times 2 is 6. I'm just adding 3 each time, so 6 plus 3 is 9, 12, 15, 18, 21, 7, 14, 21, oops, 21, that's a 21. So then my lowest common multiple is 21. And then we have to identify what our multiplier is. What did we multiply by? We multiplied 3 by 7, and we multiplied 7 by 3. So this is our multiplier. And 21 is your new denominator. Let's shift this up a little bit. Okay, so now we are on step number 4. Already on step number 4. I'm going to rewrite my fraction, but I'm going to leave some space. And I'm going to come back in there and I'm going to multiply by my multiplier. So 3 was multiplied by 7, top and bottom. And then 7 was multiplied by 3, top and bottom. So then what do I have? I have 5 times 7. Don't worry about this negative, just bring that negative over. 5 times 7 is 35. 7 times 3 is 21. Minus 3 times 3 is 9. 7 times 3, we already know that. We know the denominator will be 21 because it's the lowest common multiple. Okay, so now we have negative 35 minus 9. So I'm going to rewrite that here. So negative 35 minus 9. What do we do with our denominator when it is the same denominator? Just bring it over. Do nothing with it. Just bring it over. Okay, this is where if you want to use counters, you may. I'm going to use a modified version of counters because I really don't want to draw 35 minuses. To me, that seems excessive. So I'm going to say if I have 35 minuses, and then I'm going to have 9 minuses. What do I have? First of all, do I have any zero pairs? Do I have any pluses and minuses that will cancel out? I don't have any pluses here. I have 35 minuses here. Let's add a dot, dot, dot. And then I have 9 minuses here. So truly, what do I have? I have 35 minuses and 9 minuses. So my total is I'm going to have minuses. And how many of those minuses will I have? Well, I'm going to have 35 plus 9 minuses. So 35, I'm using my fingers, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. So I'm going to have a total of 44 minuses. So I'm going to come back up here and say that I'm going to have minus 44 minuses over 21. And again, we can see if it simplifies. 44, let's keep that minus here. We just need one minus. So 44 is 4 times 11. And then 21 is 7 times 3. We already know that. There's nothing that's the same here. 4, 3, 11, and 7 are very different numbers. So there's nothing to cancel out. So this is our final answer. All right, guys, I hope you enjoyed this video on adding and subtracting fractions. These are improper fractions. These are regular type of fractions, mostly with subtraction and negatives. If you have any questions, please let me know. Again, if there was a mistake, let me know where the mistake occurs, so that way we both can learn from my mistake. And as always, thank you so much for watching. Like, share, and subscribe. Thank you.